Close your eyes for 1 second. Now picture this. You're standing outside at night, staring up at the stars you think you're looking at right now, don't you? You're not. Every bit of light you see up there is old news, it's the past. And there's one place out there whose light took 13 billion years to reach us. 13 billion years. In this video, we're going to a place where science hits its limit and imagination takes over. Let's start by redefining the word far. When most people say something is far away, they mean another city. Worst case, another continent. That's the biggest far our brains are built for. But in space, far means something completely different. Take Voyager 1. It's the farthest man-made object in existence. It's been traveling for over 47 years at more than 38,000 miles per hour. And after all that time, all that distance, it's covered barely one light day. One light day out of 13 billion light years. Let that sink in for a second. Now zoom out further. Our own galaxy, the Milky Way, is 100,000 light years across. And we're not even alone out here. We belong to something called the Local Group, a cluster of more than 90 galaxies, all bound together by gravity. Our closest big neighbor in that cluster, Andromeda, is 2.5 million light years away. Keep that number in your head, because what I'm about to show you is going to make it look tiny. Its name is JADES GSZ140. Sounds like a password, right? But that string of letters and numbers is hiding something incredible. When NASA's James Webb Space Telescope first caught its light, scientists froze. Because this wasn't just a distant object. It was a snapshot of the universe when it was only 290 million years old. Think about that. The universe today is roughly 14 billion years old. So 290 million years in. That's basically its infancy. Its first breath. To put that in perspective, before Webb, the Hubble Space Telescope's most distant confirmed galaxy was seen at a redshift of about 11. Webb just shattered that, reaching a redshift of 14. That single jump represents hundreds of millions of years further back in time than we'd ever seen before. Back then, there was no sun, no Earth, no us. Just raw hydrogen and helium and a handful of massive, violent stars many times bigger than our own sun. Rocky planets like ours. They probably didn't exist yet. Carbon, oxygen, iron, the building blocks of a planet like Earth, simply hadn't been made yet. Even a planet like Proxima Centauri b, the closest known exoplanet to us today, would have been impossible back then. The universe hadn't built the ingredients yet. For a moment, imagine you're actually standing in that galaxy. Look up. The sky is far more crowded than ours, because the universe hadn't expanded yet. Galaxies were packed closer together. Light everywhere, explosions everywhere, constant motion. The stars up there are enormous, burning so hot they'd die out in just a few million years, which, on a cosmic clock, is barely a blink. This isn't some quiet, peaceful night sky. It's loud, chaotic, alive. The universe itself is still figuring out what it wants to become. So how do we even know any of this? The James Webb Space Telescope isn't your average telescope. It sees in infrared, light that's completely invisible to our eyes. Why does that matter? Because the farther away a galaxy is, the more its light gets stretched toward red and infrared as the universe expands. Older telescopes simply couldn't see it. To them, this light didn't exist. Webb's mirror is nearly 7 times larger than Hubble's. That's what let it catch something this faint, this far away. And how do we measure the distance? Every element leaves a unique fingerprint in light. Scientists studied that fingerprint and found this galaxy sits at a redshift of 14, which is exactly where the Z14 in its name comes from. Now stay with me because this part is genuinely strange. When that light left the galaxy, it was 3 billion light-years away from us. Today, that same galaxy is 33 billion light-years away. Wait, how does that even make sense? Here's the trick. A light-year measures the distance light traveled, not where the object is right now. While that light was making its 13 billion-year journey to us, the universe kept expanding. The galaxy kept drifting further away the entire time. What we're seeing is a freeze frame, a single photo from 13 billion years ago. What happened after that, we'll never know. The light that would show us its current state is still traveling, and it may never actually reach us. So, is this the farthest place that exists? No, it's just the farthest place we can see. Beyond it lies the edge of the observable universe, a sphere with a radius of about 46 billion light-years, which means its full diameter stretches over 93 billion light-years in every direction from us. Past that, possibly billions more galaxies, possibly structures we can't even comprehend. We're peering through a tiny window into a house that's far, far bigger than the window itself. Here's the part that gets me every time. Jade's GSZ-140 isn't some dead relic. It exists right now, somewhere out there in real time. We just can't see its current form. A lot can happen in 13 billion years. Life on Earth took about 4 billion years to go from a single cell to us. This galaxy has had 3 times that much time. Maybe there are stars there now, planets, entire solar systems. But before we even leave our own solar system, let's talk about scale closer to home. Our sun isn't just a ball of light in the sky. It's so massive that over 1 million Earths could fit inside it. And Earth itself. We're the 3rd rock from the sun, sitting in what scientists call the habitable zone. Not too hot, not too cold, just right for liquid water to exist. Now, travel outward, past Mars, past the asteroid belt, past Jupiter, a planet so large that all the other planets in our solar system combined could fit inside it, with room to spare. Keep going. Past Saturn's rings, past Uranus, past Neptune. You'd think that's the edge, right? It's not even close. Beyond Neptune lies the Kuiper Belt, a vast frozen ring of icy rocks and dwarf planets, including Pluto. NASA's New Horizons spacecraft took 9.5 years just to reach Pluto, traveling at over 30,000 miles per hour the entire way. And even Pluto isn't the edge of our solar system. Keep going further, and you'll eventually reach the Oort cloud, a massive, spherical shell of icy debris that may stretch nearly 2 light-years from the sun in every direction. Some scientists believe this is the true boundary of our solar system's gravitational influence. 2 light-years, just to leave our own cosmic backyard. And remember Voyager 1, the fastest, farthest human-made object ever launched. It hasn't even reached the Oort cloud yet. At its current speed, it won't arrive there for another 300 years. And once it does, it will take another 30,000 years just to pass through it completely. Let that settle for a moment. We haven't even left home yet, and already the numbers stop making intuitive sense. This is the trap of thinking about the universe. Every time you think you've found the edge, there's another edge past it, and another distance beyond that one. Our solar system alone, from the sun to the outer edge of the Oort cloud, might be nearly 2 light-years across, and that's just the very first step. We'll never know, and honestly, that might be the most beautiful and the saddest thing about the universe. If this blew your mind even a little, hit like and let me know in the comments. Do you think there's life out there right now? See you in the next one. Nova Dread.